In this video, we will look at the syntax of simple input and output. Eventually, we would want to write standalone Matlab programs which accomplish various tasks. One aspect for most of these tasks would be to be able to take in inputs from the user, store them as variables, do some manipulations, and display the output. Input statements read in values from the standard input, which here is the command prompt. The input function can be used as an assignment statement. To call it, a string is passed, which is the prompt that will appear on the screen. For example, say I want the user to enter the value of a radius that I'll be using later in my program. Say I enter 3. The value 3 is assigned to the variable r. If a character or string input is desired, the character s in quotes should be added after the prompt. Say I want to store the name of the user in the variable username. I would pass an additional argument of s in quotes to tell the input function that it should be expecting a string. Now, the string Melinda is stored in the variable username. Let's say you don't specify that you're expecting a string. Then you should enter the input in quotation marks. What would happen if I do not enter my name in quotation marks and do not tell input that I'm expecting a string? It spits out an error. The input function was looking for a value and not a string, and hence the error. Now, coming to output statements. The two basic output statements that you would use most frequently in Matlab are disp and fprintf. You can use output statements to display strings and results of expressions. fprintf also allows for formatting or customizing how you want to display the output. The simplest is disp, which is used to display a string or the result of an expression. The usage is as simple as this. You can display a string or the result of an expression. You can also display strings using fprintf. But fprintf can do much more than just displaying strings. It can also print formatted output. What is formatted output? Let's see that with an example. To the fprintf function, first a string, which is called the format string, is passed, which has the text as well as the formatting information. In the above example, %d is the formatting information and is sometimes called a placeholder. It specifies where the value of the expression that is after the string is to be placed. The character in the placeholder is called the conversion character. It specifies the type of value to be printed. D stands for decimals, F stands for floats, E for exponential notation, C for characters, and S for strings. \n at the end is a special character called the Newline character, and when the string is printed, the cursor moves to the next line. You can check what would happen if you did not have the Newline character. The cursor didn't move to the next line, and the result is just messy. A field width can also be included in the placeholder in fprintf. It specifies how many characters total are to be used for printing. For example, %5d would indicate a field width of 5 for printing an integer. If you're printing a float, you can specify how many digits after the decimal point you want to have. For example, %6.2f would mean use a field width of 6 to print the number and print 2 digits after the decimal point. Let's test it out. Matlab used a field width of 3 to print the integer 5 and used a field width of 6 to print 4.986 and used only 2 digits after the decimal point, and hence it rounded 4.986 to 4.99. So the next question should be, what happens if more numbers are supplied to be printed than there are format specifiers? For example, we see that format specifiers are simply reused. Instead of passing numbers separated by commas after the format string, we could also pass a vector or a matrix. If a matrix is specified, the elements are taken down the first column, then the second column, and so on. For example, here, Matlab would print 2 numbers using a field width of 3 each and go to the next line. Since we supplied a matrix of values to print, it took the entries of the matrix column by column, and hence we got 1 4 on the first line, 2 5 on the next, and 3 6 on the next line. So what would you do to print the matrix row by row? You want to print the entries of the rows one by one. So you need a placeholder for each of the column entry followed by the new line. Since there are 3 columns, you would need 3 placeholders, and you need it to take the entries row by row, and hence you would supply the transpose. So this is a cool trick to print a matrix. This might not seem too intuitive at the beginning, but if you keep at it, it will start to make sense.